We're going to look at example 3A in your section 4.7 notes. So we're going to have one of these indeterminate forms, and in fact in 3A if we plug in 0 here, we're going to get 1, and evaluating this exponent as you go to 0 is infinity, so that's the form that we have. So in this case we want to use logarithms to help us rewrite the problem. So the first thing we're going to do is whatever expression you're taking the limit of, you're going to let that equal y. So I'm going to take and let y equals 1 plus 4x to the 3 over x. And then we're going to rewrite that expression eventually like this, because we know e and ln, because their inverses cancel each other, so it's just really a fancy way to write y. So if you're looking at the limit of your expression, it's the same as looking at the limit as x goes to 0 of e to the natural log of y, and really what you're evaluating the limit for is this exponent spot. Okay, so that's going to come up towards the end of this problem. Okay, so we already have our expression for y. We're going to take the natural log of both sides. Okay, the nice thing about taking the natural log is we have the power property for logs, so the power can come down in front. All right, so remember we want to take the limit as x goes to 0 of the natural log of y. We're trying to find this exponent spot, so we're going to go ahead and do that. Okay, so the limit as x goes to 0 of the natural log of y is the same as the limit as x goes to 0 of this expression. So I'm going to go ahead and join 3 with the natural log of the quantity 1 plus 4x in the numerator. Okay, we have the x in the denominator. So if we tried to evaluate, we'd have a 0 downstairs. We put 0 here, we'd have the natural log of 1, which is 0. So we have that form. So we're ready to do L'Hopital's rule. Okay, so the derivative of the denominator, of course, is 1. Okay, the derivative of the log, we're going to write 1 plus 4x, and then its derivative goes in the numerator, so I have a 4 there. Okay, so this ends up being the limit as x goes to 0. We're going to go ahead and multiply the 3 times 4 and get 12. And really, the only denominator we have is the 1 right here. Okay, so we are ready to evaluate. Okay, so if we plug in 0, we get an answer of 12. Now, keep in mind, this is not our overall answer, right? We're trying to find the limit as x goes to 0 of our expression. We said it's the same as this. Okay, so let's go ahead and write this down. Okay, so the limit as x goes to 0 of y, remember y is our original problem, so that's the limit we're trying to find, and that is equal to e, okay, the limit as x goes to 0 of the natural log of y. Okay, so the good news is we've done all the hard work. We found the limit as x goes to 0, the natural log of y is 12, so the limit for this problem ends up being e to the 12th power, and that does it.